To do is go through a little tutorial to bring you guys back onto what we're going to be discussing for this unit. And for this unit, we're going to go back to the lovely triangle, also known as the triangle. All right. Now, when you guys were going through geometry, because I'm teaching geometry on the other days, so I know should have been at least presented to you because it has been assessed. We talked about triangles, and the first type of triangles we talked about was right triangles. And right triangles are very important for a very special reason. Kevin, do you know why? What did we first start about right triangles? What was that first kind of rule that we learned about right triangles? There's a special theorem that we like to use. That's right. And the only reason why we know that it has one angle that's 90 degrees because it had that box, or it needs to right 90 degrees. But why do we care about why do we care about a right triangle? What does that help us? What theorem does that allow us to use that was initially? Starts with the P. Pythagorean Theorem. And Pythagorean Theorem, what that meant states was when you have three sides of your triangle and you have a right angle, the relationship between the two legs and the hypotenuse is a squared plus b squared equals c squared. Now, we're not going to get into a lot of this this class period. We're going to talk more about that actually when we get into 4.3. But I want to just go back to remind you guys. They're like, oh, OK, all right, Pythagorean theorem. OK, I remember that in my geometry, working my way through. But now, later on in geometry course, they kind of took away giving you all three sides. And instead, then they started introducing an angle. So they say, well, what about if I give you a right triangle, but I only give you two sides this time and an angle? Does anybody remember now what type of functions we used to solve a problem like that? What? Trig functions, right? So what we talked about was sine of theta, cosine of theta, and tangent of theta, right? So we said, hey, if you can't use Pythagorean theorem, we can use trig identities, which is the ratio of two side lengths of a triangle, which was sine, cosine, and tangent. And to represent their ratios, what we did is, remember, I'm going to go put that angle back in there. If we were given an angle, theta, the one side of a triangle that always remains constant is what we call the hypotenuse. Now remember the hypotenuse. What I like about the hypotenuse is that it is directly across from the 90-degree angle, and it's also the largest side of your triangle. So we always have the hypotenuse. But depending on where theta is going to tell us what our other two legs are. So if here's theta, then our adjacent side is between theta and your right angle. And what we call the opposite side is opposite of theta. But remember, this is all arbitrary. This all depends on where your theta is. Because if I say, what if I talk about this angle? If I say, well, what if I want that to be the angle I'm talking about? Well, then, now this is your adjacent side, and that's your opposite side. OK? So the hypotenuse is always going to remain constant. But your adjacent and your opposite is going to depend on which angle you're talking about. Does that make sense? Because remember, just adjacent is always between the angle and your 90-degree angle. All right. So let's not deal with the green. Let's deal with the red. So by the lovely acronym of Sohcahtoa, Emily, do you remember what sine represented? So Aaron, do you remember? So what sine represented? What ratio of side lengths of the triangles? Opposite over hypotenuse. Brittany, cosine? Jason over hypotenuse. Tangent. Anybody? Anybody? Yeah? Opposite over adjacent. Oh, guys, there we go. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this is all stuff coming back from memory, and that's good. It's really good. All right? Because we're going to get into this much more deeper next unit. So you guys need to remember all these different ratios. Now, I know some of you are introduced to them. Some of you are not. So I'm going to introduce them myself. But we have all these. We can also talk about the reciprocal functions. The reciprocal functions are not the inverse functions. We're going to get into inverses later. The reciprocal function of sine is cosecant of theta. And the reciprocal of opposite over hypotenuse is hypotenuse over opposite. The reciprocal of cosine is secant of theta, which is hypotenuse over adjacent. And the reciprocal of tangent is cotangent, which is adjacent over opposite. OK? Everybody cool? Cool with that? That just means the ratio when you're given these two. OK? So now let's talk about a unit circle. So over here, we have a Cartesian coordinate, x and y axis. All right? Ladies and gentlemen, the main important thing about a unit circle, can you see over there, Izzo? Yeah. Can you see me now? Oh, OK. All right. So the main important thing about a unit circle is that the unit circle has a radius of 1. So remember we talked about radians and so forth, and I just said, hey, it has a radius. We talked about the measure of radian. Before then, it didn't matter what the radius was. But now when we're talking about a unit circle, the unit circle has a radius equal to 1. All right? So now I told you guys about memorizing the unit circle and about knowing all the points. I'll give you the easiest 4 points to make sure that you always remember. And these ones are pretty easy to understand. Right? So those are the 4 most basic points without getting really deep into what the other points are on the unit circle. But we're not going to go into that right now. I just want to kind of explain what we're going to do when we have points on the unit circle. So the next thing I'd like to do is draw a triangle on the unit circle. Now, I point down the unit circle. Gabby, a point is made up of what? What does a point contain? An x and a y. Very good. Now, if I said from here, the origin, over to this point is x, what distance would that represent, Gabby? Where would you say, what distance is x? This side or this side? Yeah, that's your x, and that's your y. Would everybody understand how I labeled my triangle x and y? Yes? Tatiana, what would you say is the distance of the hypotenuse? If I have a point on the unit circle, what would be my hypotenuse? What would be the length of this hypotenuse? What is the length here? From here to here? What is it? What's the radius of the unit circle? OK. The radius, you're going to want to write this down because you're not. Oh, ooh. Write it down. So, Michael, the radius of the unit circle is what? One. Thank you very much. The radius of the unit circle is 1. OK? So therefore, ladies and gentlemen, if I have a point that's on the circle, the distance from the origin to that point is also going to be 1. All right? Now, if we have a point x, y, let's go and determine what would be the sine and cosine of each one of these. Here, it says, let's say, let's say here's our angle, which we call a central angle. All right? So if I was asking what your angle is going to be, it's good. Split ends help you out. If I was going to ask what the sine is, you would say opposite over hypotenuse. Well, what's the opposite of this triangle? Y. What's the hypotenuse? 1. So this is equal to y over 1, which is just equal to y. The cosine, adjacent over hypotenuse. X over 1, which equals x. The tangent is going to be opposite over adjacent, y over x. Cosecant, that's going to represent now, the hypotenuse over opposite, so 1 over y. secant, hypotenuse over adjacent, 1 over x. And my cotangent is going to be x over y. You guys see how these are all reciprocals? These are reciprocals of these functions. All right? Now, the one important thing, the last thing I'm going to leave you with on this, ladies and gentlemen, these ratios and these points, what they equal x and y, only relates when you have a point on the unit circle. So ready? Only when you have a point on the unit circle. So if I say sine and you say, oh, it's the y coordinate, make sure that that point is on the unit circle. All right? Don't just say, oh, it's that coordinate, but not verify it's on the unit circle. It has to be on the unit circle for us to say, oh, sine of theta, that's just the y. All right? That's only when it's on the unit circle. Cool? OK. There is my 10-minute lecture. Cool?